Good evening and glad to be here. Thanks, Jose, for inviting me to this forum. So I'm Naveen Kamat. I lead up the data and AI services practice for Kyndryl. Kyndryl, if you have not heard of the name before, Kyndryl is a managed infrastructure services spin-off from IBM. Essentially, we are celebrating our now 2 years anniversary post the spin-off in November. In terms of scale, we have around 90,000 people, resources strong. We are having around 4,600 customers globally, around 3,000 plus patents. And post the spin-off, we have launched new practices like applications, data and AI that I'm part of as well. Now talking about engaging, as we engage with our clients around their sustainability agenda, one thing that's becoming quite obvious is that data is an underpinning to any such imperative or initiatives around sustainability, right? And there are a lot of challenges when you talk about data. For example, there are data coming in from many different sources, data exists in different silos, there are many different standards to conform to, there's a different taxonomy, right, as far as KPIs are concerned, and how do you align with the UN SDGs and some of that. And how do you basically integrate this data around KPIs, what you're getting around various metrics, around the telemetry from devices and all of that, how do you integrate that with your business workflows? So basically it calls for having a proper data strategy, it calls for having data architecture that can enable not only collection of data, but aggregation of data around your sustainability KPIs and all of that, and then basically drive to actionable insights which can then be integrated with your business workflows. I'll take a couple of examples in terms of how we have been looking at this, both in the IT and the non-IT space. So in the IT space, essentially, we have looked at all of our data centers within Kyndryl and also our customer data centers. And we have looked at collecting data from various, using sensors around temperature, humidity within the data center, various information around, how the airflows happen within the data center, and using all of that to then run AI models to get to a more optimal energy, sort of a footprint for the data centers, right? Including how do you consolidate some of your workloads, all of that, right? How do you basically optimally run your resources within a data center? And this has resulted in close to around 4 million in savings post the spin-off, savings, attributing almost 16,000 megawatt hours of energy usage reduction. Around 18,000 megawatt hours of solar energy generated to sort of support our data centers. So this basically helps you optimize your PUE, the power usage effectiveness for a data center, and brings down that spend significantly. Now we also have observability solutions that can look at what your overall IT footprint is. Right? So essentially you can start to look at, so this is a console view that gives you a sense of what workloads are running on which platforms, assuming you're running on multiple cloud platforms, let's say AWS, Azure, or on-prem, hybrid. It'll give you a view of what kind of energy spent you're having, what kind of carbon footprint are you incurring, right? And if you go a further level down, it shows you a view of the geographic distribution in terms of where your operations are probably more red versus green in terms of the thresholds that you have set in terms of energy consumption. And going a step further, you can actually bring in AI into this to say, okay, now you have this kind of a footprint, how can you optimize this, right? Based on patterns, based on heuristics, how can you optimize your energy spend across your IT operations? What kind of recommendations can be generated? And if those recommendations are adopted, what kind of energy saving is then possible can also be forecasted. Right? So the point essentially is you can use some of these solutions, whether it's on-prem, whether you can use them in the context of your cloud operations, look at your resource usage, resource spends, and then basically optimize your entire IT carbon footprint for your IT operations. Sometime back, there was this concept of DevOps, and then the whole security thing came into it. So it became DevSecOps. So security was ingrained into how you did your development in your operations, how you deployed your code into operations and all of that. I think it's going to be pretty soon that we'll see sustainability coming into DevSecOps, right? I mean, we'll probably see a sense of DevSec sustainable operations coming into play as we go forward. A couple of non-IT examples that I also want to talk about. So we do quite a bit of work around, let's say, automated quality inspection in manufacturing setups, or essentially looking at precision printing using Vision AI on premium bottles and all of that, or in a bottling kind of a context, looking at how can we improve plant utilization based, and also let's say the water spend and water consumption based on various supply chain and other metrics. However, this particular use case that we kind of looked at was in the context of firefighter safety. Now, in a lot of geographies, urban fires, wildfires, you have firefighters getting into those situations where they are exposed to hazardous gases and all of that, right? Carbon monoxide, nitrogen dioxide. So the idea was to have a wearable device that goes along with the firefighter when they are in these situations, and that device basically generates, based on the sensors that are inbuilt in there, the exposure to these hazardous zones, and then triggers alerts if the exposure is beyond acceptable threshold levels, right? Both for the individual, the firefighter who's out there in the field, and also to the, what is called the commander for the task force that's out there, to then basically guide the personnel that are out there in the field appropriately, right? Now, this is quite significant in terms of, ensuring better health conditions for people who are out there in the field, handling these kind of situations. As per some studies, cancer is the #1 killer of firefighters, right? And I think the thing to note here is that in a lot of these situations, mobile phones are not allowed. So the whole situation, the whole solution was basically built on this premise of, mobile phones are not allowed, so you need to have a device that the firefighter is allowed to carry, and that is able to capture all of this data and then sort of being able to generate some of these actionable insights from those wearable devices. Right? So this was one such solution. Now it can obviously be extended to a lot of other situations for worker safety in, let's say, oil and gas, or a chemical industry, or mining. A lot of places where there's hazardous conditions. You can imagine how this can be extended in the context of employee safety, worker safety, and all of that. Another very interesting solution that we worked on was around waste management. So essentially be able to use various endpoint devices from which you can collect data, whether that is through drones or through mobile phones or whatever that is. You collect this data and then essentially bring it into an AI engine where you can look at, is there a particular region where there is waste concentration, whether there is, land garbage, or whether it's plastics or any of that, and then basically run AI models to do anomaly detection, look at, providing meaningful insights to further downstream stakeholders, whether that is civic or municipal bodies, whether that is manufacturers, whether that is, various entities that can take action on that waste concentration, right? That's happening around maybe lakes, or around industrial areas, or whatever the situation there might be. And then the actions that you take basically are around recycle and recover and all of that, right? How do you sort of either do the segregation, or basically do recycling, or any of that. So this was another such solution that we looked at. And the way this solution really came into being was we actually ran a hackathon. This was a hackathon that we ran with Reva University, and also, I'm not sure if Harish Shenoy is here. Harish Shenoy is from Plastic Fisher. So we actually got together, we ran this hackathon. This was a hackathon that was run across 700 plus teams globally, almost 20 countries that participated. Kyndryl sponsored this hackathon. And what we did was these teams then basically came in and presented their solutions for plastic management around using various vision AI models. We basically gave them a data set with various images, and they ran these AI models on these images. And essentially it was to look at detecting plastic waste concentration around river bodies, around oceans. Because a lot of time what happens is this plastic gets degenerated from rivers and then flows into oceans, and that kind of compromises the biodiversity, the life within oceans and all of that, right? So how do you use AI to detect plastic waste concentration early in that whole cycle from rivers to oceans, and avoid microplastics from getting into the ocean? So that was the whole purpose of the hackathon. And the good part about it is this was an idea that actually got generated the last time when we were here at the TIA summit, right? So we had Harish and I, the Kyndryl team, we sort of got together, we sort of started ideating around this. So the TIA summit, I always mention to Jose, is not only for networking and learning, but also a place where new ideas come about. So this was a good thing about, I think, what we did here. So in summary, I think essentially it's very important to look at how data plays a role when you're driving a sustainability agenda, when you're looking at an ESG agenda, not only from an instrumentation standpoint, but also how you aggregate all of this data, how do you sort of run insights, actionable insights around it, and then basically be able to integrate it with your business workflows from a risk and performance standpoint as well, right? So that's essentially what I had. Thank you, and yeah.